Hello and welcome everyone to this video which will cover the solutions to the Opportunity Class Placement Test Mathematical Reasoning paper from 2023. Now this is a series of videos and this will be part 1 of our series. This test paper is available on the New South Wales Government website. So this is our first question. Question 1. An F shape is made out of all the squares as shown. How would the F shape look after it has been turned a quarter of a turn clockwise? So, if you think about a clock, the clock handle will go this way, and that is what we call clockwise. So, anti-clockwise, as they asked us of, is turning this way, the other way around. So we want to turn it a quarter turn. So if you think about a clock, it's currently facing like this, the F shape. So we're going to turn it, this should be this way. Okay, we're going to turn it this way, anti-clockwise, okay, anti-clockwise, and we're only going to turn it a quarter. So then when we turn it a quarter, it should be facing lying down on its long side like that, and that looks like option E. Number 2, Amber wants to balance these scales. Which of the following methods would balance the scales? Okay, so we have 12 and 14 kilos on this side, which if we add together will give us 26, and on the other side we have 19. So let's go through the options. If I add 5 kilos and then 7 kilos on the right, so on the right side is here, let's add 5 and then add 7. 9 plus 5 is 14, carry the 1. 7 plus 4 is 11. So we have 31. Now 31 is not the same as 26, so it will not be balanced, so 1 is out. So all the ones that say 1 are out. Now, let's try with method 2. Add 9 kilograms on the left and then 16 kilograms on the right. So right now we have 19 on the right and 26 on the left. We want to add 9 to the left and 16 onto the right. Let's try add. Start with the left. 6 plus 9 is 15, carry the 1. We have 35. On the right we have 35. Since we've eliminated all the other options, the answer must be B because we know that 2 is correct. 3. The diagram is a map showing the positions of Nyla and Oscar's front doors. Now, Nyla's ruler measures the distance in millimeters. The scale is 1 centimeter on the map, represents 10 meters in real life. How far apart are Nyla and Oscar's front doors in real life? So we're going to measure. Let's zoom in and have a look at this ruler. Okay, the ruler is going from 40 until 150. So to measure this distance here, what we're going to do is 150 minus 40. And when I do that, we get a distance of 110 millimeters. Now the question is telling us that 1 centimeter is 10 meters in real life. What is this in terms of centimeters? Well, 10 millimeters in a ruler is equal to 1 centimeter. So 110 millimeters will be the same as 11 centimeters, and we do that by removing a 0. So if 1 centimeter is 10 meters, 11 centimeters must be 110 meters in real life, which is option A. 4. When the puzzle below is completed, each row and each column will contain a correct number sentence. What does the triangle represent? Okay, so let's go around. 14 plus 13 is 27. Now 27 minus 3 will fill in the blanks. What's that? 27 minus 3 will be 24. Now something times 3 is 24. You know from your times tables that 8 times 3 is 24. 8 times 6 is something. 8 times 6 is 48. Now for our final number sentence, 48 minus our triangle is 10. We can work backwards by subtracting 10 from 48. When we get 38, and that must equal the triangle. So C is our answer. 5. Which of the following numbers is closest to 2? The best way of figuring this out is by making everything a decimal. So we'll start with the easy ones. 2.5 is the same as 2.5, because half is 0.5. 1.5 is 1.5. Now 3/4 you should know is 0.75, and we have one whole here. Now a third we will simplify by saying is 0.33. So 2/3 will be 2.33. You can imagine 2 and 2/3 will be 2.66. Now, the issue here is that on either side of 2, you can get bigger and smaller, right? So it could be 1.5 and here will be 2.5. So it depends on how far from 2 it is. It's not about if it's bigger or smaller, okay? We want it to be the closest we can to 2. 1.5 is out, okay, because there's something that I can see here that is even closer to 2. Same way, 2.66 and 2.5 are out, because 2.33 is closer than both of those on the bigger side. So now it's between 1.75 and 2.33. We can do 2 wholes minus 1.75, and we get 0.25. On this side, we have 2.33 will minus 2.00, and you get 0.33. You can see that this one is further away than this one, which means that 1.75 or 1 3/4 is your final answer. 6. What number do you get if you add 11 thousands, 11 hundreds, 11 tens, and 11 ones? So let's try that. 11 thousands means that we have 3 zeros after 11. 11 hundreds means that we have 2 zeros after 11. Notice that I'm always writing from the end, because then I can place these values in the correct column and add them up properly at the end. 11 tens means that we have 1 0 and 11. And 11 ones means that no zeros and just 11 at the base. So now we add 1, 2, 2, 2, 1. Now make sure you pick the correct option. You can eliminate the ones that look wrong. And then between here is 1, 2, 2, 2, 1, which is option D. 7. Tristan has $20. He wants to estimate the change he'll receive when he buys 3 items at this prices. To estimate the total cost, he rounds each price to the nearest dollar, then adds the rounded values together. How much change does his estimate get? So we round to the nearest dollar. We look at, let's say it was like 7.45. Just an example. We look at the number immediately after the decimal and see, is it bigger or smaller or equal to 5? If it's bigger or equal to 5, we round this number up. If it's smaller, then we round it down to 6. Okay, so let's try that with all of our combos. First, we have 6.45. Now, like I said, we look at this number. Is it bigger or smaller than 5? It's smaller, right? So we're going to round down, get rid of the cents, and just write $6. The next one, 2.35. Is this number bigger or smaller than 5? It's smaller, so get rid of the cents, round down to 2. Last one, 8.85. Is this number bigger or smaller than 5? It's bigger, so we can actually round up, give it some extra cents, and we get $9. We can add. 8 plus 9 is 17. We get $17. He had 20. How much change do we get? $3 estimate. 8. Andrea has these two objects, each made of identical cubes. If she breaks up the cubes, how many of the following objects below can she make? So if you see this object here, it's simply a formation using 4 cubes. And even though you can only see 3, I know there's a hidden one at the back, or else this one wouldn't be floating like this, okay? So essentially, we're just going to count the total of all of the cubes available and then divide it by 4. So here we have 1, 2, 3, 4. 4 times 1, 2, 3, 4, 5, 6. 6 times 4, which is 24, right here, plus, here we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Again, 6 times 4 is 24. If we add this, 2 plus 2 is 4. 4 plus 4 is 8. We're 48 altogether. And now we'll divide that by 4. Divide by 4, we get 1, and then we get 2. So we have 12 lots of this object, which makes our answer D. Nine. Maisie's building a wall using bricks one layer at a time. She always completes one layer before she starts the next layer. Each layer is made from 6 bricks. Maisie has 26 bricks and she uses them all. Which layer is she working on when she lays her last brick? So we have 6 bricks in each layer. So what we can do is divide how many bricks she has by 6 to see how many layers she has. 6 into 26 will go in 4 times, we get 24. Remainder 2. What that means is that she has 4 whole layers and she has started to lay her bricks one at a time. We have 2 bricks already laid. So that means we have 1, 2, 3, 4, and then she's working on her 5th layer, which means the answer here is B. 10. Oliver has a box of 16 colored discs. 5 discs are red, 2 are green, 8 are blue, and 1 is yellow. So I'm just using our letters to represent. He picks 1 disc at random from the box. Which of the following statements are correct? It is certain that he picks a blue disc. The word certain means 100% chance, so 1 is not correct because it only has 8 out of a total of 5 plus 2 plus 1, 16. Okay, so that's why whenever there's a statement 1 that you can see, it's not correct, right? Because we said that 1 is not correct. Now 2, it is equally likely that he picks a blue disc or does not pick a blue disc. Now actually 2 is correct because remember we have 16 altogether and 8 of them are blue. So the chance of picking a blue is 8 on 16. Now what is the chance of not picking a blue? Well, it's the other colors. 5 plus 2 plus 1 is also 8 on 16. So these are equally likely, and that's why 2 is correct. And the third one, it is possible for him to pick a yellow disc. It's not likely, but it is possible. So 3 is correct. So the answer is 2 and 3, which is option D. 11. Omid has a 1-liter measuring jug. It contains 10 mils of water. He has some identical blocks. He drops 2 blocks into the water and then they sink. The water level rises up to 150 mils. Omid drops 5 more blocks into the water. What is his new water level? Okay, so we start at 100 mils. Now after we drop these 2 little blocks in, it's going to have risen to 150 mils. What that means is that each of the blocks will rise the water level by how much? We'll find the difference first between 150, that gives us 50 mils, and we can divide that by 2 to get each block is 25 mils. So that means each block will let it go up by 25. So now he drops 5 more blocks into the water. So let's say 25 times 5, get 25. 10 plus 2 is 12. So we have to add 125 mils to our current level of 150 mils. Add, we get 275 mils, which will make the answer B. A restaurant has a target to sell 150 drinks each day. The graph shows how many drinks they have sold so far today. How many more drinks do they need to sell to reach their target? Okay, so let's actually count these by zooming in here. Have a look here. Between 0 and 10, there are 1, 2, 3, 4, 5 blocks. What that means is that each block is equal to 2. So when we count, we must count like 2, 4, 6. So T is 6, okay? But let me write it on this side so it's a bit less confusing. Here, we know that this is 10, right? Because we have the bolded line. Another 10, that's 20. Here is in line with 30, so 30. And here it's in line with 50. So now we've counted everything. We will add them up together. 50 plus 30 plus 20 plus 6. We have 6. 5 plus 3 is 8 plus 2 is 100. We want to see how many more drinks we need to sell. The target is 150, as you can see here. So we do 150 minus the amount we've sold so far, 106. 5 becomes 4. Lend the 10, we get 4. 4 minus 0 is 4. And 1 minus 1 is 0. So the answer is 44 drinks, or option A. 13. Sean starts with the number 53 and follows the instructions 5 times. If the number you can have is odd, add 1, or if it is even, divide by 2. After following the instructions 5 times, what number does Sean have? Right, we start with 53. Is it odd? Yes. Now this is the first round. Okay, let's count the rounds. We add 1, 54. Okay, now the second round, we have 54. Is it odd? No. Is it even? Yes, so we'll divide by 2. 54 divided by 2, it's on the side here, we get 2. We get 4, we minus 14, goes in 7 times with no remainders, so it'll be 27. Now 3. 27, is that even or odd? It's odd, so we will add 1. 28. Fourth round, 28. Even or odd? It's even, so we'll divide by 2. We get 14. In the last round, we have 14. Is that even or odd? Now that's even, okay? So then we'll just divide it by 2 again. And we get the answer of 7. Okay? So 7 is B. All right, 14. Shape P has an area of 2 centimeters squared. So this is 2 centimeters squared, and you can see that by counting 1, 2. What is the area of shape Q? So you can either split up all of the blocks and count them individually, or easier, we can do 3 times 1, 2, 3, 4, 5, 5 by area of a rectangle, and we get 15 square centimeters, which is C. Okay, 15. 4 bananas weigh the same as 6 apples. A shopkeeper puts fruits into bags. Bag 1 has 10 bananas, 9 apples. Bag 2 has 6 bananas, 12 apples. And bag 3 has 16 bananas and 3 apples. Which of the following is correct? So 4 bananas, B for bananas, is the same as 6 apples. I'm going to simplify that by dividing the numbers by the same thing that goes into them, which is 2. When I divide both of them by 2, that means that 2 bananas will be the same as 3 apples. I'm going to use that to help us. Okay? What I'm going to try and do is make everything in terms of just one of them. Okay? So I'm going to make everything in terms of the bananas. So we have 10 bananas in bag 1. the 9 apples, I want to change this into bananas. 3 apples is 2 bananas, so 9 apples will be the same as triple, so times that by 3, 6 bananas. Instead of 9 apples, I want to write 6 bananas. So 10 bananas plus 6 bananas, bag 1 will be 16 bananas. Bag 2, 6 bananas and 12 apples. 12 apples. How many times of 3 apples is 12 apples? We have to times 4. Whatever we do to one side, we do to the other. We times 4, we get 8 bananas. So instead of 12 apples, we're going to write 8 bananas. 6 plus 8 is 14. And the last one, we just have 3 apples here. So 3 apples was 2 bananas, remember? So we go 16 plus 2 is 18 bananas. So now, which one do we know? Well, 15, 16, 14, and 18 are the weights. So all the 3 bags have different weights. 16. Which of the following statements is or are correct? Okay, so statement 1, all rhombuses are parallelograms. Parallelograms are just a quadrilateral, a 4-sided shape that have parallel lines on this side and on this side. Rhombuses actually do, because the diagonals or the sides run parallel, so it is a parallelogram, so 1 is correct. That means that B and C are out, and E, because 1 must be correct. Okay? All rectangles are kites. Now this is not correct. A kite is a special type of a quadrilateral, and in fact it's not a rectangle, because a rectangle, the opposite sides must be the same, whereas a kite, the adjacent sides are the same. Okay, so 2 is not correct. Now 3, all quadrilaterals are squares. That's not correct. We have so many different types of quadrilaterals. We have parallelograms, rhombuses, kites, rectangles, all the ones we've mentioned. So C is not correct. So D is out, and that's why A is the answer. 17. Selena makes fences around square pieces of land. Each fence has posts that are 2 meters apart. There is a post at each corner of the square. To make a square with side length 4 meters, she needs 8 posts as shown in the picture. How many posts does she need to make a square with a side length of 10 meters? Okay, you can see here that's a demonstration of one of the sides. So it actually looks kind of like this probably. Okay, and each side will have 2 bits of this wood and 3 posts. Okay, and that will make up a total of 4 meters. So if I wanted to make up a side of 10 meters, so let's actually draw it out. Maybe I'll draw a nicer square so we can visualize it. 10 meters means that it's 5 lots of 2 meter stretches. Okay, so we need a post, 1, that's 1 lot, 2, 3, 4, and 5. You can see now that I've divided it up into 5 portions. But how many posts did we use? 1, 2, 3, 4, 5, 6. 6 posts per side. What you must be careful of though is that we do share the corner posts. So I'm going to just be safe and draw it out so that each side will have 6 posts like that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now we will count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 posts all together, which means the answer is B. Let's zoom out to see the question. These thermometers show temperature outside and inside. What is the difference between the temperature outside and inside? Okay, so let's zoom in. You can see here The difficult part of this question are the little meters, the measurements, right? Between 5 and 0, there are very many little lines. So you can see there's a big line and a small line. So the big line actually represents the actual degrees, 1, 2, 3, 4, 5. And that means that the small line represents a jump of a ½ degree Celsius. So here we have 5 degrees, we have 6 degrees and a half, 6½ degrees Celsius. And for this one, we can go up to the nearest number we can see is 20, and we have 21, 22, 23, 24 degrees. So the difference now, we will subtract 24 minus 6.5. Okay, I'll put a 0 there so that we can minus 3. This becomes 5. We can't minus 6 from 3, so we'll borrow. 13 minus 6 is 7. We have 17.5 or 17½ degrees Celsius, option E. (19) Jake has 3 different building blocks. He stacks all 3 on top of each other in different ways. What is the tallest stack he can make? To make the tallest stack, you want to optimize, or you want to use the biggest side on each of the different blocks as the height. What is the longest side here? It's 5. So we can tilt it upwards so it kind of looks like this and use that to our advantage as the height, because we want to make it as tall as we can. Here it's also 5, and here it's actually 7. Okay, so then we can add all of these sides together to make the tallest stack we can. 5 plus 5 is 10, and then we have 7, and the tallest would be 17 centimeters. And then this would be the last one for this video. I'll have a following part with the last 15 questions. 20. Maya has 2 identical squares x and y. She divides squares x into 64 equal-sized small squares. She divides square y into 8 equal-sized triangles. She shades some squares on x and some triangles on y as shown. How many more small squares must Maya shade on x so that the area is the same on both diagrams? Now, she told us that there are 64 altogether. Right now, we've shaded 1, 2, 3, 4, 5, 6, 7. Only 8 of 64. Now, if you have a look at our square y, there are 8 triangles together. We have shaded 3 on 8. To be able to compare these two, we must make the denominators the same. And to do that, we'll make this one have a denominator of 64. 8 times 8 is 64. So whatever we do to the bottom, we do to the top. 3 times 8 is 24. Now you can see there's a pretty big difference between 24 and 8. And if you minus it, you know that's exactly 12. So 12 more squares needs to be shaded in order for this to sorry, my bad. It's not 12, it's 16, isn't it? Okay, so we need 16 more squares to be shaded, or C, okay, for this to be the same in area. Okay, so we have completed a bit more than half of the paper. Please follow up with part 2 if you'd like to see the solutions from question 21 to 35.